09. The topic of the exercise is stationary points. The name of the chapter is further differentiation. So this is our second episode on this exercise. So we have already done one episode. In that episode, we have solved question number 1. There were a lot of parts of that question. And today we are going to start from the question number 2. So let's start. So I hope that this is visible to you. So let's do. Okay. Question number 1 coming up. Question number 2 and its first part we will do here. So the question number 2 is that question number 2 is showing up on your screen. Okay. It says A part. Here y is equals to under root x plus 9 by the under root x. Okay, this is the question. Okay, the statement of the question is that to find the coordinates of the stationary points on each of the following curves and determine the nature of each stationary point. Okay, so we will derivate it at stationary point. So first of all, I am going to make the shape little friendlier for the derivation. So this is x raised to power 1 by 2 plus 9 into the x raised to power minus 1 by 2. Now I will take the derivative. Dy by the dx will be equal to 1 by 2 comes on the side x, and this will become minus 1 by 2 plus 9 minus 1 by 2 come on the side, and this becomes x minus 1 by 2 minus 1, and that will be equals to minus 3 by 2. Okay. So the dy by the dx will be equals to 1 by 2, and that bring that downstairs. So that will become under root x plus minus, that will become minus. So this is 9 by 2, and that will come under this and this. This is my derivative. Okay. So we will make this derivative equals to 0. Let's see what happens. So we will make at the stationary point and the dy by the dx is equal to 0. Okay. So I will write this as 1 by 2 under root x minus 9 by 2 under root of the x cube will be equal to 0. Okay. So now this will be, we can find the value of the, I can take it to the other side. So we will have 1 by 2 under root x equals to 9 by 2 under root x cube. Okay. So this will become this is basically 1 by 2 under root x, and this is 9 by 2. This is x into under root x. The x cube, that is x into x into x. So one of the x will become outside the radical sign, and the 1 will remain inside. So okay, come. So Okay. So under root x will be cancelled, 2 and 2 will be cancelled. You are left with the 1 divided by 9 by x. So the x will be equals to 9. So this is the value of the x. Now I will put that value of the x in that equation. Okay. So y will be equals to under root 9 plus 9 by under root 9. So y will be equals to 3 plus 9 by 3. So the y will be equals to 3 plus 3. So y will be equals to 6. So the coordinates of this point are 9, 6. Now we have to decide whether this is a maximum point or the minimum point. For that purpose, I have to take the second derivative. So dy by the dx will be is equals to I can write it like this: 1 by 2, bring the x upstairs, minus 1 by 2, minus 9 by 2, bring the x up, so that is minus 3 by 2. So d square y by the dx square will be equals to 1 by 2 into minus 1 by 2 into the x raised to power will become 3 by 2 minus 9 by 2 into minus 3 by 2 into x raised to power, it will become minus 5 by 2. So the d square y by the dx square will be equals to minus, this will become 1 by 4 x raised to power 3 by 2 minus plus 9 3 are 27 divided by the 4, and that will come downstairs x raised to power 5 by 2. Okay, now I have to decide. I have found the second derivative, and after finding the second derivative, I have to decide upon the nature of this. To find the nature, what I will do in the second derivative, I will put the x value at x equals to 9. So my second derivative is this: d square y by the dx square will be equals to, this is minus 1 divided by the 4 into, in the place of x, I am going to put 9 raised to power 3 by 2. Then you have a positive sign, 27 divided by 4, and you will have 9 raised to power 5 by 2. Okay, d square y by the dx square will be equal to minus 1 by 4. When you take 9 raised to power 3 by 2, it will be 27. Okay, plus 27 divided by 4 into 3 raised to 9. Let me check on the calculator. 9 raised to power 5 by 2. So 9 raised to power 5 by, its answer is 243. 243. Okay, now the d square y by the dx square will be equal to, you need to do this calculation, minus 1 divided by 4, and downstairs you multiply 27, bracket close. Then you have plus 27 divided by bracket 4 multiply 243, bracket close, equals to, this is 0.0185. This is basically positive, so this is a minimum point. Coordinates of that minimum point are 9, 6. Let me check. Question number 2A part, the minimum point. Okay, so because we do not have that much space on our board, so I hope you understand this. It's simple. We derivated it and then we made that expression of the derivation equals to 0 to get, because at the stationary point the dy by dx is 0. So once you know the value of the x, then I put that value of the x in the original equation. From there I found the value of the y of the for the stationary point. So now I know that the stationary point's coordinates are 9, 6. Then I found, to find out the nature of the stationary point, I found the second derivative. So the first derivative, you will differentiate it further and you will get the second derivative. So in the second derivative, I put x equals to 9 and I found that the answer is positive. If the answer of the second derivative is positive, that means that it is the minimum point. So this is how you will do the question number 2 of the exercise 8B, episode number 2 we are doing on it, Pure Mathematics 1 coursebook. So I hope that this question is clear to you. So let's go to the next question. So we are going to the next question, sir. Okay. Okay, so we are moving to the next question. It is very hot and humid today here. And so question number 2 is B part. He says y is equals to 4x square plus 8 by x. Okay. This is the curve. Let me read the question. Find the coordinates of the stationary points on each of the following curves and determine the nature of each stationary point. We are doing question number 2, B part. The equation of the curve is y equals to 4x square plus 8 divided by the x. So first of all, we are going to find the derivative. For this, I will make the shape little friendlier. So y will be equals to 4x square plus 8x raised to power minus 1. So the dy by the dx will be equals to 4 into the 2 into the x plus 8 into minus 1 into the x raised to power minus 2. So the dy by the dx will be equals to 4 2s are 8x and minus 8 divided by the x square. So at stationary point, the value of the dy by the dx is equals to 0. So we'll make 8x minus 8 divided by the x square equals to 0. So 8x is equals to 8 divided by the x square. Bring it here. So x cube will be equal to 8 divided by the 8. That is equal to 1. So the x cube, take the third root on both the sides. So the third root of the 1, so that will be 1. Okay. Now I need to know the x coordinate of that, the y coordinate of that thing. For that purpose, I will put y equals to 4x. In the place of x, I will put 1 plus 8 divided by 1. So this will be 4 plus 8, and that will be 12. So the coordinates of the stationary point are 1, 12. Okay. So these are the coordinates of the stationary point 1, 12. Now we will find the second derivative to find out the nature of the stationary point, whether this is a maximum point or the minimum point. So I will take my dy by dx. Dy by the dx is dy by the dx. That is equals to 8x minus 8 into x raised to power minus 2. So I will write my first derivative. Then I will differentiate it again. And that will give me the second derivative, d square y by the dx square. That will be 8 minus 8 into minus 2 into the x raised to power minus 3. So d square y by the dx square will be equals to the 8 plus 16 divided by the x cube. So at the x coordinate of the stationary point is 1. So at x equals to 1, is equals to 8 plus 16 divided by the 1 and its cube. That will be equal to 8 plus 16. That is equals to 24, which is positive. So that means the minimum point. So that means that the minimum point is, this stationary point is the minimum point. So 1 comma 12 is the minimum point. So let me check the answer, sir. So 1 comma 12 is the minimum point. So this is how you will do the question number 12. And it's B part. So I hope that this is clear to you. Question number 12, it's B part. 1 comma 12 is the minimum point. Okay. Very easy, simple, straightforward question. Question number 2, B part. This is exercise 8B. This is the second episode on this exercise. And we are doing the Pure Mathematics 1's course book. And the topic today is stationary points from the further differentiation. My name is Ferhan Mazher and I am from Sargodha. Sargodha is a small city in Punjab, Pakistan. Today is, today is 11th of September 2025. And it's right now very hot and humid. So let's go to the next question. The next question is question number 2, and it's C part. I hope the question number 2, B part, is clear to you. Okay, so we are going to the next question. The next question coming up on your screen is question number 2, and it's C part. Okay, question number 2, and it's C part. Okay, question number 2 and it's C part. Then question number 2, it's C part. Y is equals to x minus 3 whole square divided by x. So this is the C part. The question is, find the coordinates of the stationary points on each of the following curves and determine the nature of each stationary point. Okay, so I will make this shape a little friendlier. So y will be equal to x square minus 6x plus 9 divided by the x. So make this x under everything. So this will become x, this will become 6, this will become 9 divided by the x. So y will be equal to x minus 6 plus 9 x raised to power minus 1. Okay. So now I will differentiate it, derivate it. So the dy by the dx will be equal to 1 minus 0 plus 9 into minus 1 into the x raised to power minus 2. So my dy by the dx will be equal to 1 minus 9 divided by the x square. You know that at the stationary point, at the stationary point, dy by the dx is equal to 0. So let's make this 0. So 1 minus 9, 1 equals to 9 by x square. So x square will be equals to 9. So the x square is equals to 9. So take square root on both the sides. So the x will be equals to 3. So now I know the x value. Here I can also take the x as negative and positive both. So this is positive, negative. So now I need to find out the y value. The value for the y will be y is equals to, if I take positive 3, it will be 3 minus 3 whole square divided by the 3, and that will be 0. So the first coordinate will be 3 comma 0. Then I will put minus 3, so that will be equal to y equals to minus 3 whole square divided by 3. So this is minus 6. Minus 6 here is 36. 36 by 3. So that is 12. So the other point will be, the one stationary point is 3 comma 0. The other one will be minus 3 comma 12. So one stationary point is this one. The other one is this one. You see, we got two stationary points. One is 3 comma 0, and the other one is minus 3 and minus 12. I did not put a negative there. Oh yeah, there was a negative here. This is minus 3, minus 3. So this will be minus 12. So this is minus 12. Sorry. Okay. Now I have to find out the nature of the point, whether this is a stationary, this stationary point is a maximum point or a minimum point. For that purpose, I will take the second derivative. Okay. So this is my first derivative, dy by dx equals to this. Okay. So I know my first derivative, dy by the dx is equals to 1 minus 9 into x raised to power minus 2. I will find the second derivative. This is 0 minus 9 into minus 2 into the x raised to power minus 3. So my second derivative is, this becomes 18, positive 18 divided by the x cube. Okay. Now I have two stationary points. I will put their x values one by one. So at x equals to 3, the d square y by the dx square will be equals to 18 divided by the 3 cube. So that is 18 divided by 27. So that is 2 by 3, which is positive. So the point 3 comma 0 is minimum point. Okay, so that stationary point is minimum point. Then at x equals to minus 3, so the d square y by the dx square will be equals to 18 divided by minus 3 and its cube. So it is 18 divided by minus 27. So this is minus 2 by 3. So this is negative. So it means that the minus 3 comma minus 12 is a maximum point. So this is how we will do the question number 2. It's C part. I hope this is clear to you. Question number 2, and it's C part. So look at this question. Question number 2, C part we are done. Let me check from the book. He says minus 3 comma minus 12 is the maximum point. Okay. And 3 comma 0 is the minimum point. So this is how we will do the question number 2, and it's C part. Question number 2, and it's C part. Okay. So let's go to the next question. The next question coming up on your screen is question number 2, and it's D part. This is exercise 8B. And this is the second episode we are doing on this exercise. And we are solving right now question number 2, and we are going to attempt the question number 2, and it's D part. Question number 2, and it's D part. Question number 2, it's the D part. So here an equation is given. Curves equation is given. Question number 2 is D part. He says y is equals to x cube plus 48 divided by the x plus 4. So we have to find the coordinates of the stationary points on each of the following curves and determine the nature of each stationary point. Okay, so dy by, so first of all, make the shape friendlier. X raised to power minus 1 plus 4. So you will have dy by the dx equals to 3x square plus 48 into minus 1 into the x raised to power minus 2 plus 0. So the dy by the dx will be equals to 3x square minus 48 divided by the x square. Now, at stationary point, the dy by the dx is equals to 0. So you will have 3x square minus 48 divided by the x square equals to 0. Okay. Now I will take this to the other side. So you will have 3x square equals to 48 divided by the x square. Okay. And so, or you can, if I take 3 common, so another way of doing this is, let me show you. Take 3 common. So you will have x square minus 16 by the x square equals to 0. So this 3 goes there, is gone. X minus 16, so this will become x plus 16 by, so 4 by x into x minus 4 by x equals to 0. So from here, I will find 2 values of the x. So it will be x plus 4 by x equals to 0. So x plus equals to minus 4 by x. So it will be x square equals to minus 4, which is not possible. The x square cannot be minus. Okay, I will make this thing equals to 0. So this will be x equals to 4 by x. So x square will be equals to 4. Take the square root, so you will have x equals to plus minus 2. So it means that the x values are 2. And 2 values of x I got. One is plus 2, one is minus 2. Now I will find the y value for each of them. So I know that at x equals to positive 2, the y will be equals to 2 cube plus 48 divided by the 2 plus 4. So this will become 8 plus 2, 4 plus 4. So this will become 28, 28 plus 8. That will be 36. So the stationary points coordinates will be 2, 36. So 2, 36 will be are the coordinates of one of the stationary points. Okay. So when the x is equals to minus 2, the y will be equals to minus 2 and its cube plus 48 divided by minus 2 plus 4. So that is minus 8 minus 24 plus 4. So that is minus 28. So you will have minus 2 comma minus 28. So this is my second stationary point. So there are two stationary points. One is 2 comma 36. The other one is minus 2 comma minus 28. Now I have to find out the nature, whether this stationary point is a maximum point or this stationary point is a minimum point. For that purpose, we have to what we have to do, we have to find the second derivative. Okay, so we know the first derivative. The first derivative is here. Can you see this? Dy by dx is equal to 3x square minus 48 by x square. So let me shift here so you can see that also. So I know the first derivative dy by the dx is equals to 3x square minus 48x raised to power minus 2. So I will find the second derivative. D square y by the dx square will be equals to 3 into 2 into x raised to power 1 minus 48 into minus 2 into x raised to power minus 3. So my d square y by the dx square will be equals to 6x plus 16, 1, 8 and 1, 9 divided by the x cube. So when the x is equals to 2, so let's see what will be the value of the dy by the dx. D square y by the dx square, that will be 6 into 2 plus 96 into the 2 and its cube, and this is a positive value, so that means whatever is answer, that will be positive. Okay, that means 2 comma 36. Positive means the minimum point. Okay, then at x is equals to, then at x equals to, what is the other point? The x is minus 2 is that. Yeah, when the x is equals to minus 2. So you will have d square y by the dx square will be equals to 6 into minus 2 plus 96 into minus 2 and its cube. This will be negative, this will be negative. So this thing will be basically negative. You can find the answer on the calculator, but it will be negative. So if it is negative, that means it's a maximum point. So that means the minus 2 comma minus 28 will be a maximum point. So let me check from the book. Question number 2, D part. Minus 2 comma minus 28 will be a maximum point and 2 comma 36 will be a minimum point. Our answers are right, sir. So this is how you will do the question number 2 and its D part. Okay, the equation of the curve was given and we have to find out the coordinates of the stationary points, and we derivated it, and then we made the derivative equals to 0 because at the stationary point the derivative is 0. From there we got the value of the x. The value of the x was plus 2 and minus 2. Then by using those two values of the x, we found two values of the y by putting the x in the original equation. So now we got two stationary points, 2 comma 36 and minus 2 comma minus 28. Then we found the second derivative, and in the second derivative we put the first point, which was 2 comma 30. In the x we put 2, and we found that its answer is positive. So that means that 2 comma 36 is a minimum point. Then we put x equals to minus 2 in the second derivative's expression. The answer is a negative. So negative means that this point is a maximum point. So minus 2 comma minus 20 is a maximum point. So this is how we do question number 2, D part, the exercise 8B, episode 2 we are doing. Okay, so let's go to the next part, the question number 2. And it's we have done the D part. Now we are going to do the E part. You see, question number 2 and its E part. We are going to attempt question number 2 and E part. Okay. So this is exercise 8B. I'm going to attempt the question number 2 and its E part. Here the y is equals to 4 under root x minus x. So this is the equation of the curve. For y is equals to 4 under root x minus x. Find the coordinates of the stationary points on each of the following curves and determine the nature of the each stationary point. Okay. So first of all, I'm going to find out the y is equals to 4x raised to power 1 by 2 minus x. Okay. So the dy by the dx will be equals to 4 into 1 by 2 into the x. 1 by 2 minus 1, so this will be minus 1 by 2 minus 0. So the dy by the dx will be equals to, this will become 2 divided by the under root x. Okay, so this is my first derivative. And at stationary point, the value of the dy by the dx is 0. So I will make this thing equals to 0. So that means the value of the something, let me check, something went wrong. 4 under root x minus x. Okay. So I bought that 1 by 2 on the side and I decrease the value, and that will be minus 1 by 2 and minus x. Its derivative will be 0. Okay, so you are left with only 2 divided by the under root x. So when I say 2 divided by the under root x, I make the derivative equal to 0. So what will happen? My four under root x minus x. So 4, 1 by 2, the value of 1 by 2 minus 1, that's minus 1 by 2, minus, oh sorry, I made a mistake here. This is minus 1. That's why I was stuck. Okay, so this is minus 1. Now it's correct. Okay. So now better you can take it to the other side. 2 by the under root x is equals to 1. So the under root x will be equals to the 2. Take square on the both sides. Under root x square will be equals to 2 and its square. So the x will be equals to 4. Now I know the value of the x. I can find the value of the y. Okay. Put this value of the x in this equation. Y is equals to 4 into 4 raised to power 1 by 2 minus 4. So this will be 4 into the 2 minus 4. So that is also 4. So the coordinates of the stationary point are 4, and 4. So you see, when the derivative of x, I by mistake put here 0, and which went wrong. So from here, when I came here, I realized that something has gone wrong. So we came to know that x derivative is 1, not 0. Okay. So by mistake, I put there 0. So now I know the coordinates of the stationary point. And now we will find the nature of this stationary point. So if you want to find out the nature of the stationary point, you will have to find out the double derivative. Once you know the double derivative, in that expression, put x equals to 4. And if it will be positive, it will be a minimum point. If it will be negative, it will be a maximum point. Okay, so now I will take my dy by the dx. So you have dy by the dx equals to, this is 2x raised to power minus 1 by 2 and minus 1. This is my first derivative, dy by the dx. So what I will do, I will derivate it again. I will find the second derivative. So it will be d square y by the dx square equals to. So this will become 2 into minus 1 by 2 into x raised to power minus 1 by 2 minus 1, that is minus 3 by 2. Okay, then minus 0. So my second derivative is d square y dx square, and that 2 to cancel, so you will have minus 1 and divided by, this means x 3 by 2, which means minus 1 divided by the x and under root x. Or you can write it like this, no problem, okay? Okay, so this is right. Okay, now we have the coordinates of the stationary point. The stationary point is 4, 4. So now in the place of x, I will put 4 here and I will see what the answer is. Okay, so okay. So my d square y by the dx square will be equals to minus 1 divided by the 4 raised to power 3 by 2. So this will become minus 1 divided by the 2 raised to power 3. So minus 1 by 8. The important thing that this is negative. So it means that the 4, 4 is a maximum point. This is what we think. Okay, let me check the answer, sir. Question number 2, and it's E part. We have 4, 4, and it's a maximum point. So this is how, my dear students, we will do the question number 2, and it's E part. You see, and equation was given to us. They asked us to find the stationary point, coordinates of the stationary point. Once we know the coordinates of the stationary point, they ask us to decide on the nature of that stationary point, whether it's a maximum point or the minimum point. For this purpose, we find the second derivative, and in the second derivatives expression, in the place of x, we substitute the x coordinate of the stationary point. And if the answer is negative, it's a maximum point. If the answer is positive, it's a minimum point. In our case, in this question, it was negative, so it's a maximum point. I hope you understand. This is the exercise 8B, and this is the second episode we are doing on this exercise. We are working on the question number 2 of this exercise. And this is Pure Mathematics 1 Coursebook. My name is Ferhan Mazher. Okay, let's go to the next part of the question number 2, and that is the question number 2, and it's F part. Okay, so question number 2, and it's F part. So here we go. Question number 2, and it's F part. Okay, so this is question number 2. And it's F part. The exercise is 8B, and we are on the episode number 2. Okay. Okay, sir. The question number 2, it's F part. It says, question number 2, F part, it says y is equals to 2x plus 8 divided by the x square. Okay. So question number 2, and it's F part. It says y is equals to 2x plus 8 divided by the x square. Find the coordinates of the stationary points on each of the following curves and determine the nature of each stationary point. Okay, so first of all, I will make the shape a little friendlier for the differentiation, and then I will find the first derivative. Okay, so my y will be equals to the 2x plus 8 into the x raised to power minus 2. Then I will differentiate it. So we will have 2 plus 8 into minus 2 into the x raised to power minus 3. So my dy by the dx is equals to 2 minus 16 divided by the x cube. Okay, so this is how you will find the first derivative. Then I will make at the stationary point the dy by the dx is equals to 0 at the stationary point. So I write here at stationary point the dy by the dx is equal to 0. So 2 minus 16 divided by the x cube is equal to 0. So 2 will be equal to 16 divided by the x cube. So you will have x cube equals to 2 will come here. So 8. Take the cube root on both the sides. So I will take the cube root. So this will be the cube root of the 8. So this will be equals to 2. Now I know the value of the x. I can find the value of the y. So the y will be equals to 2 into 2 plus 8 divided by 2 square. So this will be equals to the 4, and 8 divided by 4 is 2, so that is 6. So the coordinates of that stationary point are 2, 6. This is question number 2F part. 2, 6 are the coordinates of the stationary point. Now, once I know the coordinates of the stationary point, now I need to find out the nature of that point, whether it's a maximum point or a minimum point. For this purpose, I have to find the second derivative. Okay, so what we will do, first of all, we will find the second derivative. Okay, so my first derivative is this, dy by dx is equals to 2 minus 16 by x cube. I will take this. So you have dy by the dx equals to 2 minus 16, 2 minus 16 x raised to power minus 3. So I will find the second derivative. Okay, so that will be the d square y by the dx square. That will be equal to 2 minus 16 into minus 3 into the x raised to power minus 4. So my d square y by the dx square will be equal to 2. Its derivative will be 0. So no, it will become 48 divided by the x raised to power 4. Okay, the derivative of the 2 is 0. Okay, the derivative of the 2 is 0. Okay, I wrote there too. So you have 48 divided by the x. So at x equals to how much? 2. Okay, so the value of the d square y by the dx square will be equals to 48 divided by the 2 and it's raised to power 4. So this is 48. 2 2s are 4, 4 2s are 8, 8 2s are 16. And 16 3s are, so this is a positive value. So that means that the point 2, 6 is a minimum point. So it's a minimum point. Okay. So this is, ouch. So you see, we found that the dy, the 2, 6, which are the coordinates of the stationary point, and it's d square y by the dx square is positive. So if the d square means the second derivative is positive, that shows that that point is a minimum point. So my dear students, there were F parts in this question and we are done with it. So that's it for today. And let me bring the camera down a little bit. So my dear students, this was the second episode on the exercise 8B from the course book of the Pure Mathematics 1. We have completed the question number 2, and I hope that this video will be helpful to you. If you find this video helpful, if you find this video interesting, if you think that this video can be useful for you, for your junior students, or for your teachers or for your cousins. Please like this video. Please share the link of this video with your on your social media. You see, when you subscribe my channel, you like this video, you share the link of this video with your friends. This helps me to promote my work, and that's a great support for me. I think that it's a great blessing for me that I can make these videos, which can be helpful and which are helpful to so many students, so many students around the globe, and they can prepare by sitting at their home from these YouTube videos. They can prepare their Pure Maths 1, Paper 1. So thank you very much, everyone, for taking out time and watching this video. And so have a good night, sir. Thank you very much. God bless you all.